Pythagoras.
Hey geometers, welcome to this little slideshow on the Converse of Pythagoras Theorem, presented by the Geomanstat Trigoplex and produced by the Make Awesome Things Happen Corporation. Okay, we are going to start with some other stuff first, which will then lead on to the converse itself. Let's consider this statement. If you study in an all-boys school, then you are a boy. This statement can be broken into two parts. The first part is, you study in an all-boys school. The second part is, you are a boy. So what the statement is saying is that if the first part is true, that is, you study in an all-boys school, then the second part is true, that you are a boy. As with any statement, there is a context. In this case, the context is you are a human being studying in a school. Okay, maybe it is very obvious in this statement, but in subsequent statements that we are going to see, the context is important. Okay, to someone else, it may not be so obvious. Why is it that if you study in an all-boys school, then you are a boy? So that's when you need to explain or elaborate or prove this statement. How do you do that? Okay, what we do is we insert an additional fact that all boys schools only admit boys as students. So with this additional fact, there is a link from the first part of the statement to the second part. We call this additional fact the bridge. Alright, because it forms a bridge between the first part and the second part. Okay, so we have proven this statement to be true. Let's call this the all-boys school theorem. So suppose there is somebody else. How do we use the all-boys school theorem to prove that somebody else is a boy? For that, we need to look at the first part of the theorem. How do we show that somebody else studies in an all-boys school? Well, we could ask the school for the school records, or we could look at the school uniform that somebody else wears. These additional facts that we use, they form the bridge. So suppose we look at the school records, and the school records show that somebody else studies at that all-boys school. Or maybe we could also look at the school uniform, and we find that, hey, is that all-boys school's school uniform? Well, normally we wouldn't enter a school wearing some other school's uniform, because something will happen to you. So once we have established these facts, we can reach the conclusion that by the all-boys school theorem, that somebody is a boy. Let's come back to the all-boys school theorem again. Previously, we saw that from the first part, you study in an all-boys school, it led on to the second part, you are a boy. What if we went in the opposite direction? We call this the converse of the original statement. Converse. So the question we would like to ask is the converse valid? That is, if this is true, that you are a boy, does it mean that this is true, you study in an all-boys school? Well, the answer is, it may not be true, because you can study at a mixed school that has both boys and girls. So in this case, the converse of the all-boys school theorem is not valid. Then you might wonder, is there a theorem whose converse is also valid? The answer is yes. There are theorems whose converses are also valid. So one example is this. Okay, this is inspired by this particular web page. You can go and see it yourself. The context is there is a group of people. Okay, 100 people have joined the group. The group has 100 people in it. So if 100 people have joined the group, then of course the group has 100 people in it. The converse of this is true. That means if the group has 100 people in it, then naturally 100 people have joined the group. So in this case, this particular statement, the converse is also valid. Now let's move on to the Pythagoras theorem and its converse. Let's recap what the Pythagoras theorem says. The Pythagoras theorem says that if triangle ABC is a right-angled triangle with angle ABC equals to 90 degrees, then AB squared plus BC squared equals to AC squared. Notice I put the Pythagoras theorem in a special format because later on it's going to help us in looking at the converse of the Pythagoras theorem. Alright, so let's break this theorem down in the same way that we did with the all boys school theorem and the 100 people in the group theorem. Okay, first of all, we have the context. Here, the context is that there is a triangle ABC. So Pythagoras theorem says that if angle ABC equals to 90 degrees, then AB squared plus BC squared equals to AC squared. Okay, the converse of Pythagoras theorem is also valid, but we are not going to discuss the proof in this video. Okay, so in explicit words, what the converse of Pythagoras theorem says is, in triangle ABC, if AB squared plus BC squared equals to AC squared, then triangle ABC is a right-angled triangle with angle ABC equals to 90 degrees. So how do we use the converse of Pythagoras theorem to prove that angle ABC equals to 90 degrees for this particular triangle ABC? Well, we have to look at the first part of the converse of Pythagoras theorem. The first part of the converse would be the second part of the original Pythagoras theorem. That is, this part, that AB squared plus BC squared equals to AC squared. So we need to show that this is true. How do we do that? What is the bridge in this case? So we need to show that this equation is true. This is an equation because it has an equal sign. AB squared plus BC squared equals AC squared. Asking whether this equation is true is the same as asking whether AB squared plus BC squared has the same value as AC squared. So to show this, first we have to show that AB squared plus BC squared equals to some value, and then we show that AC squared equals to some other value, and then we show that these two values are the same. So this some value and that another value, they form the bridge. Okay, remember about the bridge? So this form the bridge. And if we can show that these two values are the same, then we will have shown that AB squared plus BC squared equals to AC squared. And then, therefore, we can reach the conclusion by the converse of Pythagoras theorem, angle ABC equals to 90 degrees. Okay, let's look at a concrete example in which we use the converse of Pythagoras theorem. So there is a triangle ABC. In triangle ABC over here, we have AB equals to 12 cm, BC equals to 5 cm, and AC equals to 13 cm. Prove that angle ABC equals to 90 degrees. So we need to write the bridge. We need to form the bridge. Okay, so we look at AB squared plus BC squared. what is it equals to? Sub in the values of AB and BC, and then we see that AB squared plus BC squared equals to 169. Then we find the value of AC squared. AC squared equals to 13 squared, which is equals to 169. So you see that the two values are the same. And therefore, AB squared plus BC squared equals to AC squared. And so we can write the conclusion. The conclusion is, by the converse of Pythagoras theorem, angle ABC equals to 90 degrees. And usually at the end, we will write proven. So what you see here is all the steps that you need to write to prove that angle ABC equals to 90 degrees using the converse of Pythagoras theorem. Okay, so you may have this question, or rather, people in the past have done this before. Can we write like this to prove AB squared plus BC squared equals to AC squared? Okay, so somebody, or rather a lot of people in the past, they have written it this way. They start with AB squared plus BC squared equals to AC squared, because that is what we are trying to prove. Then they write 12 squared plus 5 squared equals to 13 squared. And then 144 plus 25 equals to 169. And finally 169 equals to 169. So you see the two values are the same. But the problem with writing like this is not proving. This is merely verifying the result. So you cannot write like this. Because by starting with this step, by writing AB squared plus BC squared equals to AC squared, you have already assumed that the result is true without proving it. Okay, because ultimately we are supposed to prove that this is true, and yet you have started with this. With that, let's look at another good example. Here we have triangle DEF. In triangle DEF, DE equals to 45 cm, EF equals to 28 cm, and DF equals to 53 cm. Prove that triangle DEF is a right-angled triangle with angle DEF equals to 90 degrees. So once again, we need to form the bridge. Here we are trying to use the converse of Pythagoras theorem, so we need to show that DE squared plus EF squared equals to DF squared. So we start with DE squared plus EF squared. Sub in the values of DE and EF, and we find that DE squared plus EF squared equals to 2809. At the same time, DF squared is also equals to 2809. So the two values are the same. So we write, therefore, DE squared plus EF squared equals to DF squared. And hence, we have the conclusion. The conclusion is, by the converse of Pythagoras theorem, triangle DEF is a right-angled triangle with angle DEF equals to 90 degrees. Notice that in this case, the conclusion is a bit different from the previous one that we had, because we need to answer the question directly. And in this question, the question itself is a bit different from the previous one. So our conclusion is also a bit different. Alright, to sum up, these are the steps that you need to write in order to use the converse of Pythagoras theorem to prove that a triangle is a right-angled triangle with a particular angle equals to 90 degrees. Please do not leave out any of these steps, because if you leave out any of these steps, then the proof is not complete. You can pause the video now to take a longer look at these steps, or you can always rewind to the earlier parts of the video to watch them again. Okay, so we have come to the end of this little slideshow. Please go and practice on your own. 噼里啪啦，呜哗啦，这次会更好。乒乒乓乓，乒乒乓乓，人手举起高，路漫漫。